Welcome to Discovery Matters. We've never said that before, so we're saying it now.
Oh, well, why we want people to feel welcome, and discovery does matter, so...
Exactly. So we've been running this special mini-series that we call Discovery Makers.
That's right, and we met Molly Stevens, whose lab has started growing new bone tissue, and she talked about how the team effort was really important. And in episode 2, we had Nobel Prize laureate Bob Lefkowitz, and his findings are foundational to a third of all of the drugs now in the United States. And he talked about how you can't really plan to discover something.
You need serendipity.
And failure on top of that. It was brilliant.
Glorious failure. Yeah. We learned so much about what drives discoveries, and we're about to meet yet another person who has a life-defining purpose, Dorraya El-Ashry.
Okay, so tell us a little bit about her.
Well, let's hear straight from her.
What I would say to my breast cancer opponent in the ring is, we will win. You will not win. We will. Because research, in the end, is the reason for every breakthrough we've had, and research will end you.
Now, that is what I really call faith and belief in science.
Absolutely. And that is what matters in this episode of Discovery Matters.
I lead the vision and the strategy for the research program.
This is Dorraya El-Ashry.
I am the Chief Scientific Officer at the Breast Cancer Research Foundation.
Now, you're going to recognize BCRF from a previous episode. I don't know, Connor, do you remember when we met Dr. Margaret Flowers?
Yes, I do. Yeah, back in October in Breast Cancer Awareness Month.
Exactly. And we were talking about the societal aspect of breast cancer research and how that was changing in the COVID environment. And then we heard Dr. Flowers' personal story. This time, we're going to get into the science of breast cancer research and what's happening in bodies in cancer. And we're also going to understand why science is not exactly, but kind of like an onion.
Okay, no matter how much it makes you cry, it's like every time you peel a layer back, it makes you cry more.
Anyway, BCRF is the largest nonprofit funder of cancer research in the U.S., and Dorraya and her colleagues oversee which research they should pursue.
How BCRF will invest its dollars to get maximal impact in breast cancer research.
But she's not just in charge of handing out the cash, right? She's a scientist as well.
Exactly, and she has a very personal reason for focusing on breast cancer.
I grew up in a household of science. My dad's a scientist, an environmental scientist, and with his 2 girls, he pushed science and math in our house. I loved science, and when I was in the 4th grade, our president declared the war on cancer, and I thought, well, that's what I'm going to do.
Okay, so the war on cancer, that was Richard Nixon in the 70s, is that right?
As if either you or I would remember that personally. But...
not as old as I look. I wasn't even a twinkle in anyone's eye, yeah.
Oh, I was 1 year old then, so you youngster you. But history tells us that in 1971, Nixon signed the National Cancer Act. And here's what that sounded like, thanks to a clip from the Richard Nixon Foundation.
Because when we consider what cancer does each year in the United States, we find that more people each year die of cancer in the United States than all the Americans who lost their lives in World War II.
And that set off a national effort to find a cure for cancer.
So Nixon really kicked off this fight against cancer, is that right?
Maybe in hindsight, that's a bit too much credit to give him for this. It was actually scientists in the 60s who pushed Congress and the president to get funding for cancer research.
Okay, and then this is what inspired Dorraya in the end.
Exactly. In school, she started to get really passionate about biology.
Biology is the study of living things, and ultimately it gets you to the study of human diseases, which is pathology, which is what I then studied in graduate school.
Then later in college, she knew she wanted to go into cancer research. This became a more personal goal than she realized at first.
And both of my best friends' mothers were undergoing treatment for breast cancer, different breast cancers. So my one friend who was my lab partner all through college sciences, and she's now the head of dermatopathology, so she also went into cancer. Her mom died just about a month after that 5-year mark. Back 30 years ago, if you had made it 5 years, you were supposedly home free, and she died a month after. And it was crushing to her.
Her other friend's mom had a relatively small breast cancer, the kind that would be easier to treat today.
But every year we were in college, she had one metastasis, and then the next year another metastasis. And this was all in the era before we had what we call adjuvant therapy, and she's clearly someone who could have benefited from that. And again, it shows you the power of research and of us moving forward to help this.
Okay, wow.
And cancer affects everyone. I mean, don't we all know someone who has or has had cancer?
Yes, indeed, we have. Yeah.
But she lived for about 10 years with metastatic breast cancer, and the toll that took on my friend and what we went through during those 4 years of college, nights sitting up crying when she would be diagnosed with another metastasis, not studying for exams, all of that.
So I can really see how this must have affected Dorraya as well.
Absolutely. And it pushed her even further into understanding how we can cure breast cancer, because it's not enough for her to treat patients with metastatic breast cancer.
While we can treat patients, while we can extend their lives, and ultimately I know we'll get to a place where we can cure even metastatic breast cancer patients of their disease, it's still therapy. It's still toxic chemotherapy. It's still treatments and anxiety that you go through, and it's for them and their family. And so this is, though, what motivated me to focus on breast cancer as my research career and committed me to bettering the lives of women with breast cancer. And ultimately, I wanted to be involved in something that brought about the cure for breast cancer.
Dorraya spent more than 30 years doing research on breast cancer before getting to the Breast Cancer Research Foundation.
The main focus of my laboratory research over the years started with triple-negative breast cancer, trying to understand what it is that makes them triple negative. So why are they not expressing the estrogen receptor?
Their idea was that if they could re-express the estrogen receptor in these cells, it could revert them to a better biology and then resensitize them to an anti-estrogen therapy.
And we focused on a particular signaling pathway, the RAS-MAP kinase pathway, that was important in driving proliferation. But we also found that part of its action was to actually repress the expression of the estrogen receptor.
By doing that, they could make those cells resistant to anti-estrogens.
And we found that this was a reversible mechanism, and that therefore, if you could inhibit that signaling pathway with currently available inhibitors, that you could re-express the estrogen receptor, and in fact, in some of those triple-negative breast cancers, make them sensitized to anti-estrogens again. And that work actually went on to change some clinical practice in breast cancer.
While they were doing that work, this led them, almost like Lefkowitz talks about, there was a little serendipity. This led them into a whole new world.
The tumor microenvironment.
Okay, the tumor microenvironment. Let's talk a little bit more about that.
By looking into this microenvironment, scientists can figure out how metastatic breast cancer works.
Okay, so how it goes from its one place in the body where its origin is to another, right?
That's correct. And there are 168,000 women in the U.S. alone living with metastatic breast cancer.
So this is the most common type of breast cancer that people die from, right?
It is the only one that is not able to be cured, and we are making progress. There are, just in the last 5 years, are 9 new drugs approved for metastatic breast cancer, and in the last year, the first one that could actually have an impact on brain metastases.
So how exactly does metastasis work? How does cancer move from one place in the body to another?
For decades, the cancer research community has focused on the cancer cells, and rightly so. Those are the cells that grow uncontrollably, and those are the cells that ultimately kill patients. And so research has focused on what's gone wrong, what's altered, what's changed in that cancer cell.
And today we've known for at least a decade how cells that surround the cancer cell are affected.
These normal cells, these could be fibroblast cells, these could be adipose or fat cells, these could be blood cells like endothelial cells or immune cells. They're there, and when the cancer starts growing, it co-opts these cells to now help it become more aggressive, help them invade into blood vessels, help them invade into new organs. And so a focus on the tumor microenvironment is really one of the hot areas that there is going on today, especially the immune microenvironment, for example, and immunotherapy.
So Dorraya believes that we need to understand what it is that allows the cancer cell to leave the primary tumor site and get in the circulation.
But beyond that is to understand what those cells use to grow in places like the liver and the lung and the brain. And if we could have those specific targeted pathways that we could then go after, then we would cut off metastatic breast cancer at its knees.
This would make breast cancer a more manageable disease and eventually one that could be cured.
That would be, I think, our immediate and first knockout punch to breast cancer, is to stop metastasis and cut it off at its knees and allow patients then to be treated with a curable form of breast cancer and be cured of their breast cancer.
That's just incredible. So the knockout punch for breast cancer.
Yeah, and she believes that her perseverance is what led them to start to understand the tumor microenvironment and metastatic breast cancer. Because they started off, remember, with an expectation that was the current paradigm. And as we know, changing a paradigm, that's really difficult.
That's why a paradigm is what a paradigm is. Yeah.
That's right.
And we started this work on how this particular signaling pathway interacted with the estrogen receptor to repress it. That data that we got, and again, those experiments were done with an expectation of how they might come out, but the data we got was not leading us in that direction. And
so they continued with the experiments.
We found that for triple-negative breast cancers, or a subset of them, that the prevailing dogma that was out there was not the way that this signaling pathway interacted with the estrogen receptor.
It was hard for the lab to get grants and to publish articles.
But I was in a cancer center with my postdoc mentor as the director of that cancer center, and he was very supportive in terms of sticking with it, of if this is where the data is taking you, stick with it and keep pushing through.
But with that support, she pushed through. And after several years of publishing articles, she finally got her first grant to study these pathways.
Then more grants came through with that and more publications. And then it became, oh, this is a possibility. And as I said previously, in fact, we found that it's ultimately impacted clinical practice today.
So in a sense, they completely changed the field of medicine, right?
Yeah, it's kind of like, when somebody becomes a superstar and it's like, wow, an overnight sensation. And no, it's been a full career of auditions and work. And this is what kind of researcher Dorraya is. It was hard to get funding. She persevered. She looks like an overnight sensation, but it's been a career that's made her a successful scientist. Perseverance and patience.
Science does not move in straight lines. It frequently comes as an iterative process, and even breakthroughs are all built on the steps of smaller little aha moments.
She says that as a scientist, you need to follow where the data leads you.
One of my favorite quotations that is there, and I have it in my office, is that there are no failed experiments, only unimaginative interpretations of unexpected data.
So this is a little bit like what Bob Lefkowitz said. You've got to look at the bits of data that make you go, oh, that's weird.
Exactly.
And what that says to me is that if you have set up your experiment with all the proper controls and everything else that you need to have the experiment come out, and you don't get the results that you were expecting, that doesn't mean that there was anything wrong with it. It means you need to look at what that data is telling you and follow what that data is telling you and follow the lead of that data. And that might take you to a different avenue or a different approach, or as in the case of my research career, moving from triple negative breast cancer, it took us into a whole new area of the tumor microenvironment.
Today, it's even harder to get funding for cancer research because you almost need to have already proven your hypothesis to get approved for a grant.
I think the funding situation for cancer research, all biomedical research really, but cancer research and breast cancer research is at a critical point. And I think it makes it much harder to then have that space and take that time to push and to be able to persevere and yet keep either your lab open or keep your position at the university or continue to get funding.
Okay, so now it all makes perfect sense, and I can see why she's the chief scientific officer.
Funding providers who can bring funding from a number of sources then, for example, nonprofit funders. And in breast cancer, we're fortunate to have a number of nonprofit funders for breast cancer research. I think there you can then give some support that gives some security to allow you to investigate these novel or innovative or out-of-the-box kinds of thoughts.
And that creativity is needed to get the results that you need in science. So Dorraya does not look at cancer as being an onion.
Okay, so back to all those layers and you peel them back and you find new discoveries. It's not like that?
I think of it more as a shallot, because if you all know shallots, it starts with a hole and you peel layers, but now you reveal individual, other smaller onions or pieces of the shallot that have their own individual layers.
And that is why the knowledge of the tumor microenvironment is part of peeling back those individual layers.
We know now that breast cancer is not just one disease. There are at least 3 subtypes. The main subtypes, ER positive, HER2, and triple negative. But even triple negative, now as we get to the layers of that individual shallot within there, now it's going to have multiple subtypes, multiple things that drive each one of those groups of cancer growth and, the outcomes that go with that.
I really need to go and chop up a shallot now. She starts with a hole, you peel the layers, and now you reveal the smaller onions or pieces of the shallot that have their own individual. Oh, I see. Because shallots have 2 or 3
inside.
different...
They're like Russian dolls.
Right,
they are the Russian dolls of onions.
But there's so it's not just one onion with one set of layers going down to the middle. You end up with multiple hearts in a shallot. That's what she's getting at.
That's what she's getting at.
Okay.
And at each level where you get more knowledge about breast cancer, you find new things and new avenues to pursue.
At any level that we look at breast cancer and the knowledge we've gained, that goes along with that it's not linear. It goes in curves and takes you in places you didn't expect.
Okay, so if it's not linear, where is the future of this research taking us?
Frankly, she thinks that in 20 years we will have cures, plural, for metastatic breast cancer, and that we're on the cusp of preventing breast cancer from ever happening.
20 years ago, when I was asked this question, I said that I foresaw that we would be at a place where we could make breast cancer a manageable, treatable disease. And we're almost there. We have that for all breast cancer types except for advanced metastatic breast cancer. And so I think we are close to that. I think we will get to that point, and I will see that in 20 years we will have come up with cures for metastatic breast cancer patients.
So she's been following this for 20 years now. What keeps her going?
Well, she sees the progress. People live much longer with breast cancer today than when she started out, and she gets very personal about that change.
25 years ago, my aunt died from metastatic breast cancer at the age of 39 with 2 young daughters. Just last year, 2 young women who are are close to BCRF in different ways died of metastatic breast cancer. They lived longer than my aunt did, so we have made progress in 25 years. They were able to have their lives extended longer with treatment, but they still died of metastatic breast cancer. And for me, who focused my research career on metastatic breast cancer and then came to the BCRF where we have such a deep investment in metastatic breast cancer, the deaths of these two women last year was a gut punch. I really felt that I had hoped in 20, 25 years we would have come so much further. But I do know that science and research moves in fits and starts. We have just in the last couple to 5 years reached that point with metastatic breast cancer that we will make that leap now, and we will see that big leap in the future years. And so in 20 years, I hope to see that we've cured metastatic breast cancer and no woman dies of her breast cancer anymore, and that we are well on the road to preventing breast cancer from happening in the first place.
So this is just absolutely remarkable. I mean, in essentially like our lifetimes, Dodie, you know, this devastating disease has gone from being something which, you know, wasn't spoken about. It was hidden away. It was like, it was the big C word that you didn't talk about. It was essentially a death sentence.
Oh, it was a women's problem.
It was a women's problem. Yeah, exactly.
That's right.
And so now it's out in the open, and in many cases, it's
out in the open, I think, thanks to the perseverance of scientists like Dorraya.
And they've managed to make it go from being, you know, a likely death sentence to a manageable disease where...
Manageable or preventable, incredibly enough.
Or preventable.
Exactly.
Yeah, extraordinary. I love this idea of like sort of peeling back layers and understanding more, but being surprised that it's not just one central... core that you're going to, rather than an onion, it's a shallot. Yeah.
Exactly. And there's a big difference when you visualize an onion and its layers versus a shallot and what happens when you peel back a shallot. So that was a really fun visual.
Superb. So is that the end of our Discovery Makers miniseries? I'm kind of sad about that.
For this time, but we will meet more Discovery Makers in the future, but this is the end of our very first mini-series within the Discovery Matters podcast. So we will be back to normal programming next time. And you know what we're going to talk about next time? Do you want me to tell you?
Garlic.
I'll just tell you, Connor. It won't be about garlic. We're going to find out why games are so appealing to humans. And there is a scientific reason that we find games appealing.
Superb. So we're going to play games. I love it. Look, give us a rating. Thanks for listening. And tell your friends.
Our executive producer is Andrea Killen. Discovery Matters is produced in collaboration with Soundtelling. Production by Tanvir Mansoor. Our theme song was written by, who is it, Connor?
Thomas Henley, but really additional music from Epidemic Sound? Like now? Isn't it too soon? I feel end of pandemic hysteria is coming on, and it's not really there for so many people. So our theme song was written by Thomas Henley with additional music from Epidemic Sound.